Hello guys, welcome back to College Algebra. Mike coming back at you here with another video. In the previous video, we talked about nth roots and rational exponents, and we just went over how we take products, quotients, differences, and sums of nth roots or things with rational exponents. In this video, we're going to do a little bit of a recap of polynomials, and then just some of the basic operations with them, addition, subtraction, and multiplication. So just as a quick recap, what is a polynomial? A polynomial in the variable x is an expression of the form a sub n times x to the power n plus a sub n minus 1 times x to the power n minus 1, so on and so forth, all the way down to plus a sub 1 times x plus a naught, where these a's here, those guys are just real numbers. Typically, they're going to be whole numbers that we're going to be working with, but they can be any real numbers whatsoever. And a sub n is not 0. And then those exponents, n minus 1, those are non-negative whole numbers. So there's no negative powers, and there's no rational powers. If you see something like this that we have here, it's also referred to as a polynomial of degree n. You'll be seeing that once again later on in this course, but just a polynomial in just the variable x can also be referred to as a polynomial of degree n. That first term there, the a sub n times x to the n, that is called the leading term. We call a sub n the leading coefficient, and n is the degree of the polynomial. We're going to see how do these two things impact the graph of a polynomial. We're going to get to that later on in this course. And polynomials can be in more than one variable. You could have a polynomial in, say, x and y. Something like that could look like x squared, y squared, plus x plus 2y plus 5. Just anything where you have x to some power times y to some power, or just an x, or just a y, or a constant. This is typically something that we look at more in a significantly higher level math course. If you go on to take Calculus 3, that's typically where you'll be looking at these things more. But for now, for the most part, we're really just going to be, for the most part, looking at polynomials in one variable, typically x. So adding and subtracting polynomials, you can only add or subtract terms that have the same power or powers on the variable or variables. I include the option of powers and variables in case you did encounter a polynomial in more than one variable. But for the most part, if it's just a polynomial in just one variable, only when the powers on x are the same, that's only when you can add or subtract the terms. And it's very, very important, you do not subtract the powers themselves, you only subtract the coefficients. You only subtract the numbers in front of those terms with x raised to the same power. So as a quick sample here, I have two polynomials, x cubed plus 2x squared minus 5x plus 6, and 4x to the fourth plus x cubed minus x squared plus 9x plus 2, and I'm going to take the difference of these two guys. There is no x to the fourth here, there is one here, so I'm going to have minus x to the fourth, minus 4x to the fourth, be more specific. Make that a bit nicer to see. Now I have an x cubed here, and then when this minus sign gets multiplied in, we're going to have a minus x cubed. So x cubed minus x cubed, they cancel each other out. Those things are gone. I have a 2x squared and then minus a minus x squared. So that's 2x squared plus x squared, or plus 3x squared. I'm going to have a negative 5x minus a positive 9x. So negative 5x minus 9x minus 14x. And then 6 minus the positive 2 to give me a plus 4. So that should just be pretty straightforward. Shouldn't really be much of anything new here. Again, this is just a quick recap of adding and subtracting polynomials. Big thing is you can only combine terms that have the same power of x, and when you combine them, you do not add or subtract the exponents. You only add or subtract the coefficients on those guys. When you multiply polynomials, you have to multiply each term in the first polynomial by each term in the second one. Once you've done all that, you then combine like terms. You add or subtract terms that have the same power of x. So as an example here, I have 3x plus 2 times a 2x minus 7. I want to see what this thing is going to multiply out to. Now, here I have two terms. Here I have two terms. You've probably heard of FOIL, which we use to multiply two factors that each have two terms in it. So you go first, the first terms in each factor here. 3x times 2x is going to be 6x squared. Multiplying the 3 and the 2, and multiplying the x and the x to get x squared. Then we have outside 3x times a minus 7 minus 21x. Then the inside terms, plus 2 times 2x is plus 4x. And then plus 2 times minus 7, the last terms in each factor, minus 14. And then we can combine these two terms here, and we get 6x squared minus 17x minus 14. So this is a pretty common type of operation that we do when it comes to multiplying polynomials. This next one, a little bit more involved. This is not so much FOIL. You can't say first, outside, inside, last, because this thing here has 3 terms to it. So this is where we look at it as just multiply every term in here by every term in here. So we're going to make sure that that happens. So I have the x times the x squared, x cubed. X times the minus 3x, minus 3x squared. X times the plus 1, plus x. Now I have the 7 times the x squared, so plus 7x squared. 7 times the minus 3x, gives me minus 21x. And then I have the 7 times the 1 plus 7. Now let's combine some like terms here. I have plus x and minus 21x to give me minus 20x. And then I have negative 3x squared plus 7x squared to give me a plus 4x squared. So I have x cubed plus 4x squared minus 20x plus 7. So that was a little bit more complicated sample there where we multiply two polynomials, but not too bad. And something like that, maybe something a little bit more involved, is probably all you're going to see from me for the most part. After that, it's just too many terms. It's not necessarily hard, it's just time consuming and tedious. And that's not really what we want to have here. The most common polynomial multiplication that we do is multiplying it two binomials, polynomials with two terms, with squaring a single binomial being a special case. The first sample that we did all the way back here, this is one sample where we multiplied two binomials. And the squaring a single binomial being the special case. Sometimes people do get tripped up on that, and they're sort of not sure how to multiply that thing out, seeing it as something raised to the power 2. If you see something like that, just take the given factor there and multiply it by itself. So for example, if I have 3x plus 8 raised to the power of 2, I can just rewrite that as 3x plus 8 times 3x plus 8. And now we go through our typical FOILing process. First, it's going to give me 9x squared. Outside, 3x times 8, 24x. Another 3x times 8, so that's plus another 24x. And then 8 times 8 is 64. So we have, in the end, 9x squared plus 48x plus 64. So that was just a little bit of a recap on polynomials, as well as how do we add, subtract, and multiply polynomials as well. We didn't talk about quotients of polynomials quite yet. We're going to get to that later on in this course, and we're going to talk about that in a little bit of a different context. In the next video, we are going to talk about factoring polynomials. We're going to do a little bit of a review on that and how do we factor polynomials of various degree. If you have any questions or comments, please be sure to reach out to me, send me an email, send a letter to my house, send a carrier pigeon, whatever you have to do. Otherwise, until the next video, take it easy, guys.